Good evening, Niharika. So let us try to understand this question. Okay. A body of mass 200 gram is tied to a spring constant 12.5 Newton per meter, while other end of the spring is fixed at point O. If the body moves about O in a circular path on a smooth horizontal surface with constant angular speed 5 radian per second, then the ratio of extension in the spring to its natural length will be. Okay. So let us try to draw a diagram and find out what all things are working. So you have this spring moving in a circular path. So let's take this one. See, a body of mass 200 gram is tied to a spring of spring constant 12.5 Newton per meter, while the other end of the spring is fixed at point O. So you have this spring, something like this. The other end being fixed at O. So this is our point O. And you have a mass that is fixed at the other end. So here you have a mass. This mass is 200 gram. So you have this mass M equals to 200 gram. You have this spring. So this is our spring. And the spring has a spring constant K, which is equal to 12.5 Newton per meter. If the body moves about O in a circular path on a smooth horizontal surface with a constant angular speed of 5 radian per second, then the ratio of the extension in the spring to its natural length will be. So let us say the natural length of the spring is L, and you have to find L x over L. So you have to find something this one. Ratio of extension. So extension we say L dash new length minus original length over L. This is what we have to find. We have been given that it moves with a constant angular velocity omega, which is given by here omega is equal to 5 radian per second. So any ideas how we can utilize this? How we can utilize the given information? Okay, first of all, tell me why will there be an extension produced in the spring? Suppose the spring originally the spring has the length L. The spring originally has a length L. So why should there be an extension produced in the spring? Yes. Why should there be any extension produced in the spring? See, if you are moving this in a circular path, Niharika, can you answer? Niharika and Sriyuta, can you tell why will there be an extension produced in the spring?
Sir, is it because of centrifugal force?
Yes, there will be a centrifugal force experienced by this mass. So can we give the quantity of the centrifugal force? In terms of the quantities, whatever are given here, can you give the amount of the centrifugal force experienced? Very good. You tried it. You said very good that it will be the centrifugal force. So we know the centrifugal force is given as mr omega squared, right? The centrifugal force is given as mr omega squared. So we know the value of mass, we know radius which is equal to the original length, and we have omega which is given as 5 radian per second. Okay, so we can find out this force, and this force must be equal. This force must be equal to the extension produced. We can find out this force, and we can give this force to be equal to minus kx. Okay, where x is the extension produced. So we can write this, that F should be equal to the extension produced minus of kx. Okay, so F is mr omega squared should be equal to negative of k multiplied with the extension x. The extension x will be written as L dash minus L, whereas this radius is equal to the length. So I'll put it here m multiply length multiply omega squared will be equal to minus of k times L dash minus F. Okay. And our target is finding out L dash minus L over L. So the value would be m omega squared over k should be equal to L dash minus L over L. So can anyone tell the answer now? Remember, you have to take the SI units only. Your mass is given it as 200 gram. We will take it as 0.2 kilogram. Multiply omega, which is given as 5. So we take it as 5 squared. That means 5 multiply 5. Divided by K. The value of spring constant is 5. Okay. And this is equal to our required ratio. So isn't this answer 1:1? Yes, Reyuta and Niharika. Is this answer correct now?
Sir, isn't the spring constant 12.5?
This, yeah, sorry. The spring constant is 12.5. I got incorrect here. Okay, the spring constant is 12.5 here. Put the value here 12.5. You multiply here, you will get 5 by 12. Is it? Zero 0.2 multiply omega squared. And is it any of the options? Or 12.5, sorry, it's 12.5. Now you can simplify this 50 over 125. So 50 over 125 is the required ratio. So
Option 4.
yeah, it's 25 2 times and 25 5 times. So 2:5. That's the option 4. Okay. So was the question tough or easy?
Easy, sir.
Easy. Only thing you should try it out. Okay. Do not put it without trying. See, a mass M attached to free end of a spring executes SHM with a period of 1 second. So a mass M is attached to free end of a spring, executes SHM with a period of 1 second. If the mass is increased by 3 kg, the period of oscillation increases by 1 second. The value of mass M is. So you have to find the value of mass M. Okay. So let us see, use the formula time period T would be equal to 2 pi under root M by K. So time period T is equal to 2 pi under root M by K. Initially the time period is 1 second. So we put here 1 will be equal to 2 pi under root of M by K. This is your first equation. Now we make the second equation for this. Now it says if the mass is increased by 3 kg, the period of oscillation increases by 1 second. So period of oscillation now becomes 2 should be equal to 2 pi and under root of the mass should be m plus 3. This is m plus 3 divided by k. The spring constant remains the same. It does not change. Now, if you find out the ratio, divide both of them. So you get 1 by 2 equals under root m over under root of m plus 3. Square both the sides. You get here 1 by 4 equals m over m by m plus 3. Then you can solve. So m plus 3 would be equal to 4m, and hence 3 should be equal to 3m. And can we get here m, the value of m as 1 kilogram? Got it? So you should
Yes,
are
sir.
you doing the questions with yourself also?
Yes, sir.
Yes. Okay, sure. So this, I think you should try to do this question. Just hold on to it. Okay. A particle executes SHM, simple harmonic motion, between x equals to minus a and x equals to plus a. If time taken, so a particle executes SHM between x equals to minus a and x equal to plus a. If time taken by particle to go from x equal to 0 to a by 2 is 2 seconds, then time taken by the particle in going from x equal to a by 2 to a is. So a very important question here. Let us try to understand. This question is based on the equations of SHM. Okay, what all information can we get from here? Yes, what all information we get from here?
Time taken from x equal to 0 to a by 2 is 2 seconds.
Okay, so how do I relate it with my SHM then? See, for the SHM, I know the displacement equation of the SHM is given by y equals a sine omega t. Okay. I don't know the value of omega here. The omega is 2 pi by t. I don't know the value of omega, but certainly I can find out something from this information. See, the displacement is minus a to plus a. So from this information, I get that amplitude of the oscillating particle, the amplitude of the oscillating particle will be equal to a. Amplitude is equal to a. From the second information, if time taken by particle to go from x equal to 0 to a by 2 is 2 seconds. So you are moving from x equals to 0 to x equals to a by 2. That means I can put the displacement of the particle to be a by 2. So in this expression, I can put the displacement y, or if I use it like this, x equals to a sine omega t. So in this expression, I can put here at the place of x, I can put a by 2. So here I put a by 2 is equal to a sine omega t. And what is the time taken? The time taken I know is 2 seconds. So I'll write here 2. So this is, I have a by 2 is equals to a sine t is 2 seconds. So I put 2 omega. Okay. Now you cancel this a and you get 1 by 2 is equal to sine 2 omega. Now the value of sine theta is 1 by 2 at theta equal to 30 degree. Is it correct? If you have
Yes, sir.
theta equals to 30 degree, so I know that sine theta will be equal to 1 by 2. And this 30 degree I write in radian as pi by 6. Is it correct? I write it as pi by 6. So now I can write here, from this expression, I can conclude that my 2 omega should be equal to pi by 6. And hence omega should be equal to pi by 12. Is it correct? I have got the value of
Yes,
omega,
sir.
and hence I can get the value of time period using this formula. Using this, now I can get the value of time period. So see, omega is 2 pi by t. I can write here 2 pi by t to be equal to pi by 12. Okay. So pi and pi cancel, and we have 24 is equal to time period. Is it correct?
Yes, sir.
Okay. So I'm getting time period as 24 seconds. Now, so time period means time taken to complete one oscillation. One oscillation, see what does one oscillation mean? One oscillation mean you are completing one complete to and fro motion. Okay. Now let us see. So if you are going from it's something like this. Try to understand here. So suppose you take here the example of a simple pendulum. We take this example of a simple pendulum to understand this. You start from, these are the positions which I am marking. So here this is our x equals to 0, mean position x equals to 0. This is our x equals to minus a. This is our x equals to plus a. Okay. So the time period 24 seconds. It will be 24 seconds for the particle to start from x equals to 0, go to a, return back to minus, come to minus a, and again return back to 0. Or you can start from a plus a and complete one cycle. Okay. Here, so as the motion is symmetric, so for half the oscillation, if you are just taking for half the oscillation, the time taken would be equal to 12 seconds, will be equal to t by 2. Okay. And if you consider the motion from x equal to 0 to x equal to a, this is just a quarter of the oscillation. See, going from here to here, again coming here to here and coming. So this from x to a, this is just a quarter of the oscillation. Hence you get here t by 4 equals to just 6 seconds. So t by 4 is your 6 seconds. For one quarter of the oscillation, you have the time taken as 6 seconds. Now out of these seconds, see, while the particle is moving from x equal to 0 to a by 2, it has already used 2 seconds. We have already used 2 seconds. Okay. So we have already used 2 seconds. Now, how many seconds are still left to complete the remaining part?
4 seconds.
4 seconds. So which option should be correct here?
Option 4.
Option 4. Okay, we should have here option 4. 4 seconds. Okay. So this question was a good practice for the equation of SHM. Okay. If in the same question I add one more thing, let's try to do in the same question. I add what will be the velocity of the particle at this point. So can you find out what will be the velocity of the particle at this point? Yes, any idea? Both of you, can anyone give any idea? Sriyuta, can you give any idea?
Velocity is omega into root over a square minus y square.
Omega into
Root over a square minus y square.
root over a square minus y square. Okay. So we use the formula of V, and we use here V is equal to under root of a square minus y square. And here you have omega, right? So can you tell the answer now? Omega we have found out. Okay. And y is equal to a by 2. Okay. So omega we have got here. The value of omega is pi by 12. So we put here V is equal to pi by 12 under root of a square minus a square by 4. So this is pi by 12 under root of 3a square by 4, and hence we get it as pi by 24 root 3a. This is root 3a. This will be the velocity of the particle.
Okay, sir.
We get now to the next one. A particle. Here you have. So a particle of mass 250 gram executes a simple harmonic motion under a periodic force F equals to minus 25 x Newton. The particle attains a maximum speed of 4 meter per second during its oscillation. The amplitude of the motion is. So how we can relate this with the motion? Yes, how can correlate all these things? We just need to correlate all the values. Here we are given the mass to be equal to 250 gram and the force as minus 25x. Also, the maximum speed is given to us. The maximum speed or V max is known to us as 4 meter per second. So any idea to move on? We have to find here the amplitude. The amplitude is to be found out. Our target is to find out the amplitude here. So how is the amplitude related with the velocity and the force. Okay. So see, we can equate this. We are given the value of force. So force is equals to minus of 25x. And this force should be also be equal to mass times acceleration. So we get here mass times acceleration as minus 25x. From this we get acceleration as minus 25 over 250. This is 0.25x. So if you cancel this, we get here the value A as, here we get 10 to the power 3. So 250 minus 250 over 250 multiplied with 10 to the power 2 is equal to x. So this cancel, and you have here A is equal to 10 to the power 2x. So clearly, if I compare, my omega square is equal to 10 square, and hence omega is equal to 10. Okay. So since I have got the value of omega, now I can find out the value of maximum velocity. Okay. If I use the formula of maximum velocity, see, Vmax. So Vmax is equal to 1 over 2 of, sorry, not 1 over 2. Yes, any idea to find out the maximum velocity?
No, sir.
No. Okay, what's the formula of velocity we just used?
V is equal to omega into root over a square minus y square.
Okay, V is equal to omega into root of a square minus y square. So the velocity will be maximum when the displacement is minimum. If you put your displacement y as 0, so you will get your velocity as maximum. That means the velocity is maximum at the mean position. So won't you get here a omega? Won't V max will be equal to a omega? So
Yes, sir.
V max is given to us as 4. We put here 4 equals to a omega. So we get 4 equals to a multiply omega, which is 10. So what should be the answer for amplitude here? 0.4 meter should be equal to the amplitude.
Yes, sir.
Okay, and in centimeter, this should be equal to 40 centimeter, right? So we get here answer as 40 centimeter. So see, we have studied everything. We just need to correlate all the ideas. We need to see what all we have done. Take out the necessary information from it. Okay. Once you obtain the necessary information, then you can. So this is our acceleration, which is 10 squared x. And finally, we got the answer. Let's see. The general displacement of a simple harmonic oscillator. So again, you have the simple harmonic oscillator, and its displacement equation is given as x equals to a sine omega t. Let t be the time period. The slope of its potential energy u and time graph will be maximum when t equals to t by beta. The value of beta is. So the question, if you see, we have something as slope of potential energy and time graph. So if you want to find out the slope of potential energy with time, okay, so how do we get that? We have the expression of potential energy given by the formula 1 by 2 Yes. Can you give me the formula for potential energy?
1 by 2 into ky square.
1 by 2 into ky squared. And how do we get the value of k? How do we reach the value of k here? If we know the equation, if we know the equation of SHM, so how do we get the value of k? Yes. See, we are given here yes, we actually want that k, because once you get the potential energy, so you just need to determine the change of potential energy with time. So du by dt is what you have to find out, and then you have to find when it will be maximum. Okay. So let us again move to our oscillator equation, which is x equals to a sine omega t. This is what we are given. Just from this, we can find out the value of acceleration. We know that the value of acceleration will be equal to minus of omega squared multiply x. Okay. So the acceleration would be given by minus of omega squared x. And if I use my force expression, if I use the expression force, so I get here ma equals to minus of omega squared x multiply m. So again, the acceleration, I will get the same thing. So how do I get now? X is what we have as a sine square omega t. So from here, I can get only thing as omega. How do I find out the value of k then? Yes, any idea for finding out k? You have acceleration, so you can find out the force as ma. So force, if you get force would be equal to minus of m omega squared x. And maximum potential energy, if you get the maximum potential energy, the maximum U maximum potential energy is at amplitude A. So I want potential energy with time. Okay. Okay. So if you compare this and you want to find out your energy, your potential energy would be given by 1 by 2 m omega squared and multiply x. This is the expression for potential energy. 1 by 2 m omega squared x. You can check it. You will get this form only. If you get the value of k, see, you have the value of k as you can correlate here if you have f equals to minus of kx, and you also have f equals to minus of omega squared x, and put the value of f as ma. So from this you can find out the value of k, and the value of k would be equal to m omega squared. Okay. So this is the value of k, and hence you get the potential energy as 1 by 2 m omega squared x. Okay. The next thing we want to find out the change of potential energy with time. So we want here du by dt, change of potential energy with time. So that we differentiate this, you get 1 by 2 m omega squared multiply dx by dt. And this dx by dt is your velocity. You get this. So you get 1 by 2 m omega squared, and dx by dt is the velocity at that instant of time. Now this has to be maximum. This du by dt has to be maximum, and for the maximum value of du by dt, this expression should be equal to 0. Okay. So, oh sorry, the slope of its potential energy and time curve will be maximum. Slope will be maximum, that means du by dt will have a maximum value, and this will have a maximum value 1 by 2 m omega squared v equals to du by dt, and it should be maximum. So what can be the maximum value of this du by dt? Yes. Any ideas? How can we move ahead? Sriyuta?
No, sir.
No. Okay. So what if I differentiate it again? If I redifferentiate this, I have this du by dt I obtained. So this gives me the slope of this. Okay. I want this slope to be the maximum. Okay. The slope of its potential energy and time curve will be maximum. So I want this to be the maximum. So this can be maximum at a point if you get d2u by dt squared will be equal to 1 by 2 m omega squared dv by dt, which is your acceleration. So this will be maximum when you have d2u by dt squared will be equal to 0. So time rate of du by dt will be equal to 0. So you will get this maximum value. So the maximum value of this will be equal to 1 by 2 m omega squared a equated to 0. You have 0 acceleration. So 0 acceleration will be when? Acceleration will be 0 when we have x is equal to 0. But we want this value of t by beta. Okay, we are stuck somewhere. So, okay, we'll see this question in the next class. I'll try out this in the next class. Okay, maybe we'll be able to reach somewhere to find the value of beta. Okay, till then
Okay,
you
sir.
also try this question. Bye, Sriyuta. And thank you for attending the class.
Thank you, sir.